Hello everyone, welcome back to the new video. In our previous video, we explored some of the basic concepts and real-world applications of graph data structure. Today, we're going to dive a little bit deeper and cover graph traversals. There are two popular methods for traversing graphs: breadth first search, BFS, and depth first search. In this video, we are going to focus on BFS particularly, and then we'll learn how BFS works conceptually, and then we will look at the Java code together to see it in action. So let's just dive into whiteboard first without wasting any time, and then we can see how BFS works. So what is the definition of BFS? First of all, as the name suggests, it says breadth first search. Okay, it says breadth first search. So that usually means that uh, whenever we are traversing in any graph, we will have to explore all of our neighbors first before we go anywhere else. Okay, so BFS. So if you want to just simplify definition, you just say that explore the neighbors first. Okay, so for example, I'm gonna say, okay, I'm at 0 right now, right? We are starting from 0. And then if I want to do breadth first search, what I'm going to do, I'm going to 2 first, right? So 0 to 2, and I am here at 2 now. So now before I go to other branch, before I go to 3, I'll have to cover up the 1 first. So I'll do 0, 2, and then I'm going to go to 1, and then I'm going to go to 4, and then 3. So our main priority should be to explore our neighbor first, and then we will go deep. So let's say these are our neighbors, and this is the second branch, or this is the different branch of the graph. So we are not going to move any further until we have covered all of our neighbors. So this was the definition part of this graph data structure. Now we'll have to determine how we can implement this in our code. Okay, so it's going to be very simple in my opinion. So we are just going to use two data structures here, and that is going to be queue and array. Okay, so okay, so that is going to be our array and queue. Now look, let me just draw the queue first. It's going to be something like this. It's I know it's very ugly. I'm not used to drawing, so just bear with it. And that is array. Okay, so this is going to be our Boolean array. Okay, and then we can just store our elements here. Okay, 0, 1. So it's going to be 0 here. Then it's going to be 0. Then it's going to be 1, 2, 3, and then 4. In the beginning, all of it, all the values of this Boolean array are going to be false. Okay. So that's a good start. So we're starting from here now. Okay. So now we will have to focus on how we can implement the queue with this array. Okay. So let's say we are starting from 0. So right now my queue has element 0 in it. Okay. So whenever I'm adding any element, and so I'll have to make sure I'm adding all of my neighbors here as well. So inside the queue, what are the neighbors of 0? Neighbors of 0 are 1 and okay. Now we'll have to perform some checks here before we remove the element from queue and move to the different node. So first of all, this one is going to be my current node for now, and then see. So we'll have to check first if visited. Oh, I think I messed up the pen here. Uh, yeah, I think we're back. If if visited is not equal to true, then we'll have to, so first of all, print current. We'll have to print current. Then we'll have to make the visited node true, and then we'll have to move to neighbors. Okay, so we are at 0 right now. So I'm going to check first is if the visited array is true or false. Right now it's false. That means it's not visited yet. So now what are we going to do? We are going to create, we are going to make it true, and at the same time we are going to remove the element from queue. Okay. Now we are at 1 now. So what are the elements of what are the neighbors of 1? Neighbors of 1 are 0 and 4. So we are going to write it down here. 0 and 4. Okay. So now our current is here. Current is here. Now again we are going to check. And also, yeah. So as soon as you remove the element from queue, make sure you print it. So let's say we are printing 0 here. Now 1. Let's check if 1 is already there. It is already there. Is it true or false? It's false for now. So now what are we going to do? We are going to make it true, and we are going to remove it from queue, and we are going to print 1 here. Then we are going to move to 2. When I'm here at 2, what I'm going to do, I'm going to see again what are the neighbors of 2. The neighbors of 2 are 0 and 3. So I'm going to write it down, 0 and 3. Now I'm going to check if visited is true or false. It's false. I'm going to make it true. I'm going to remove the element from queue. Okay, I'm going to remove the element from queue here. So now 2 is gone. We are printing 2 here. Now 0. Check if it is false or true. It is false. So there is no point in even discussing that. So we're just going to scrape it out. Now we are at 4. Now which ones are the neighbor of 4? So what are the neighbors of 4? The neighbors of 4 are 1 and 3. Now we are going to remove 4. We are going to write it down here true. And then we are going to do the same thing with 3. We are going to remove 3. And then we are going to write it down true here as well. And we're going to check, is it false or true? It's false. It's not false, it's true. So then we are just going to remove the elements, remove all the elements from queue like that. And then we are eventually printing our output for our breadth first search. So it is very simple thing. You keep on adding the elements in the queue, whoever the neighbor is, and then you keep on removing the element from queue after updating the visited array. If the visited array's index is already false, sorry, it's already true, then there is no point in even looking at that. Just scrape it out from queue, just remove it from queue straight away. You don't have to worry about anything else. So that was our BFS. Now let's move to the coding part. Now we have understood how these things work. So that could be very easy for us to implement it in our code now. So let's move to a coding part. Okay, so here's the code of BFS. I've already written that, so I can explain it line by line to you guys. So first of all, we are starting to import all of the necessary packages that we're going to need for this code. We're going to need array list, we're going to need linked list, and we're going to need queue data structure here as well. So array list is used to create dynamic arrays that can grow as needed. Linked list is used to create a linked list that implements both the list and interfaces. Queue is an interface that we're going to need as well, that we have discussed in our explanation. So these three will be the most crucial libraries that we are going to need in this code. So first of all, we are going to define our class here. We are going to name it edge. So we know that in our edge, we have 3 things or maybe 2 things. It depends on what kind of graph is. I have just assumed here that we have a weighted graph. So I have included weight here. So it could be source, destination, and weight. So this is how you can initialize it. And then we need a constructor here to make sure it goes in there and then initializes the variables that we have created inside the class. And then we are going to create the graph with the given edges. So I have implemented this in a way that we can create a graph with dynamic values. right? And then, so first loop, what is first loop saying? It says that it initializes the each element in the graph array as an empty array list of edge objects. As you can see that it's initializing each element. So we can also say that we are creating a list of lists here. And then we are going to iterate over we are going to iterate over the array of edges. Uh, and then for each edge, it extracts the source destination and weight and adds the edge object to the corresponding list in the graph object. I'm going to show you how this actually works. Let me comment this down for you. So let's say this is our edges array. So first element, we can say that 0 and 1 are connected to each other, and the weight between them is 5. So this will be the first element of our edges array. And then second will be, let's say 1 and 3 are connected, and then the weight between them is 4, and then so on. So in this way, we are going to add each edge into our edges. So as you have noticed here, edges is the 2D array. So that's how we can define it. So 0 could be source, 1 could be edge in this case, and then 5 could be the weight in this case. And in this way, we will be able to have each of our edges stored in a perfect manner. So this was the function of how we can create the graph with given edges. Now next would be to create a function for BFS traversal. How we can do that? We can first of all created a Boolean array, as we have discussed. We have discussed all of this already in our explanation. So Boolean array visited to keep track of which nodes have been visited. And then we are going to need a queue here, right? We're going to need a queue here, as we have discussed in this explanation. Can just zoom it up for you. So we are going to need a queue here. So queue is here. Now queue dot add 0. We are going to add 0 as our first element, and then we are going to remove current. So we have already defined this, that if visitor is not true, then first of all print the current array that we print the current element as we have printed it here, system.error print align current. And if it is not the case, we are just going to remove the element from queue. So remember how we discussed that if element is already switched from false to true, we are just going to remove it from queue, and that's how we're going to do here as well. So we are just going to do it. And then once we have done all of that, we are going to move it. We're going to move to the next element, and it is going to be q dot add e dot destination. So let's say I am at this element right now, and I'm going to see what is the I want to check what is the I'm going to check what is the neighbor of 0. Then we are just going to do q dot destination, because in this case 0 is source and 2 is destination. So we are just adding that here in our code. Okay. So in this way, we have traversed through each of our edges, and we have made sure that we follow the algorithm that we have created. And this is just the main function that we're going to need. Uh, we have created the array list of graph, and then we have defined our edges dynamically. We'll call our functions, and then we'll be able to see what are the actual values of our BFS. So I have pressed the play button here for BFS, and then as you can see that we have gotten the values here 0, 1, 2, 3, 4, 5, 6. In our example, we created only till 4 values, but here is a graph of some bit more values, and as you can see, we have the output created here. So that's how you can implement the code of breadth first search. So that's it for this video. From next video, we are going to cover DFS, which is also known as depth first search. In the same way, we are going to see how DFS works first, and then we are going to implement the code for DFS.